With this question here, you've just got to make sure you give good reasons for each of your steps. So we want to show that ACD, which is this here, we want to show that that's an isosceles triangle. And with isosceles triangles, they have two angles that are the same. Okay. So in the question, we're told that these two lines, B, C, D, and E, F, G are then parallel, and on the diagram that's indicated by these little arrows. So when you're doing this question, I would just think about all of your rules you know about parallel lines, and the one that I'm going to choose is your alternate angles, which is your Z angle, and alternate angles are equal. So this angle here, if that's 125, this one would also be 125, and then I'm going to put my reason here, which is your alternate angles are equal. So that therefore means that both of these angles there are 125. The next rule that I'm going to look at is angles on a straight line add up to 180 degrees. So the straight line that I'm going to use is here. And those two angles together is going to add up to 180 degrees. So in order to find this angle here, I'm then going to do 180 minus 125, and 180 minus 125 then gives you 55. So that angle there is 55 degrees, and my reason for that is angles on a straight line add to 180 degrees. Similarly, we have a straight line here as well. So in order to find this angle, that is going to be a very similar process. 180 minus 110 is then going to give you 70, so we've then got 70 there, and the reason for that, I'll just put the arrow here as well, is angles on a straight line add up to 180 degrees. We now need to find that top angle there, and we're going to do that by using the triangle rule, and angles in a triangle add up to 180 degrees. So we can find this angle here by doing 180 minus 70 minus then 55, which gives you 55 degrees. Our rule for that is angles in a triangle add to 180 degrees, and like I mentioned earlier, the rules are just as important. So we needed to show that we had two angles the same and the third one would be different. So this is an isosceles triangle because two angles are 55 degrees and the other is 70 degrees. So we've then shown that ACD is an isosceles triangle. With this kind of question, just make sure that you give reasons for each stage you're working, and you need to be really precise with your reasons. So in the mark scheme, which is just above here, you can then see exactly what wording you need. And like I've said, there are a few different ways you can get the answer to this question, because you could have used the co-interior angle to find this angle here, then use vertically opposite, but I think this is the most logical way to get to the answer for this.